So we are going to start out here by looking at the pressure versus volume graph. So at some point way up here, our gas is going to be acting ideally, but then as we get closer to the origin, we are going to start to gain a point of inflection. So right about here is going to be our critical point. So now if we were to look at a pressure versus temperature graph, we could see that right about here is our critical point. So right about the same spot on each graph. And then if we were to go anywhere above that critical point, that means that we have supercritical values now. So we are starting to get into supercritical fluids. So let's erase this for have more room. So now, since we have this critical point and we have this inflection point, we can set our first and second derivative equal to 0 under these critical conditions. So we can have dP over dV equal to the negative RT divided by V minus B squared. And then we would have 2A divided by V cubed. So if we were to let's do the second derivative now. So the second derivative would be d squared P over dV squared. So we are going to have positive RT over V minus B cubed minus 3A over V to the fourth. So now we can set both of these equations equal to 0. So we will have negative RT over V minus B squared equal to 2A divided by V cubed. And then for our second derivative, we're also going to set that equal to 0. So we will get RT over V minus B cubed. This will now be equal to 3A over V to the fourth. So now we can take one of them and then multiply by the reciprocal of the other. So this will get us the equation of negative RT times V minus B cubed over positive RT times V minus B squared. So we got this by taking the negative RT over V minus B squared and then multiplying it by the reciprocal, which would be V minus B cubed over RT. So now on the other side of this equation, we will get 2A times V to the fourth over 3A times V to the third. So again, we got this by multiplying 2A over V cubed by the reciprocal of 3A over V to the fourth. So now we want to solve this equation for B. So our RT's over here will cancel. And this V minus B cubed will cancel with the V minus B squared, but we're still going to have one V minus B on top. And then over here, our A's will cancel. We're going to keep that 2/3. And then our V to the fourth and our V cubed are going to cancel, but we're still going to have one V left on top. So now we have negative RT. Oh, no, sorry. We are going to have negative V minus B equal to 2/3 V. So we are solving this equation for B. So we are going to get B equal to V divided by 3. So now we can put our new value for B back into our first derivative. So we will get negative RT divided by V minus, this is where our new B comes in, V divided by 3 this all squared, and it's going to be equal to 2a over v cubed. So now we have 1v minus 1/3 v, so we can rewrite that as negative RT over 2/3 v, this all squared. And then we will have 2a over v cubed still on this side. So now let's square this parentheses. So we're going to have negative RT over 4/9 v squared. And this is still equal to the same thing. So now we are going to multiply this whole equation by v cubed over 2. So now this v squared and this v cubed will pretty much cancel, but we're still going to have one more v over here. So this v cubed and this v cubed will cancel fully. And now the 2 part of this and the 2 on bottom there will both cancel, but we still need to multiply this bottom by that 2. So we are going to get negative RTV over 8 divided by 9. And this is all going to be equal to A. So if we rewrite this, we can now see that A equals negative RTV times 9 divided by 8. So that is our new value for A. So now I am going to erase some of this for I have more room to write. So I'm going to erase everything but what my A and B equals. That is all we still need to know for right now. Okay, so now that I have room on my board again, we are going to plug A and B back into the original van der Waals equation. So we are going to get P is equal to RT over V minus, this is where our new B comes in, V over 3 minus A, but we have to put the new value for A in, so it is going to be 9/8 RTV on top divided by V squared. So now, moving on to the next step, we can now take 1V and subtract 1/3 V, and we can rewrite that as RT over 2/3 V. So now on this side, we can cancel this V with part of our V squared. So we're still going to have one V still on bottom here. So we're going to have 9/8 RT over V. So now, if we can see, we have an RT over V in both terms of this equation. So we can actually take out that RT over V, and we will have 3/2 minus 9/8. So this is going to be P is equal to RT over V times, so if we turn this denominator into 8, we will have 12 over 8 minus 9 over 8. So we will get 3/8. So we are going to have this multiplied by 3/8. So now we are going to divide by our RT over V, and we are going to get PV over RT is equal to 3/8. So this 3/8 is actually equal to our Z, and our Z is our compressibility factor. Alright, so now we are going to take and solve this equation for V. So V is going to equal 3/8 times RT over P. So now if we think back to the values that we found for A and B, they both have v's in them. So we can take our new value for v and plug them back into a and b, and we're going to find the numerical values for a and b. So if we do that, we're going to have b is equal to 3/8 times RT over P, and this is all going to be divided by 3. So in this case, these two 3's are going to cancel, so we're going to have B is equal to RT over P times 8. So this is our new numerical value for B. Now let's do that for A. So we are going to have A is equal to 9/8 times RT times 3/8 RT over P. So if we multiply this out, we are going to get A is equal to 27 over 64 R squared T squared over P. So now, this is our new numerical value for A.